There we go. All right, lecture over. First, we're going to start off with a check-in review. When I looked at the check-ins last Friday, these two problems gave you all fits. Okay, this is where most of the misconceptions were. So let's start with the first one. 5 students came for after-school tutoring. Lynn's teacher assigned each of them the same number of problems to complete. Then he assigned each student 2 more problems. 30 problems were assigned in all. So if I were to draw a tape diagram, what would I do to this tape for the first problem? What would I do to it?
You can have two in there.
2 in there?
Cause
Separate 5.
Separated by 5? Why by 5?
There's only 5 students.
There's 5 students. Okay? So if we got 5 students, each one of those blocks represents a student, right? Okay, what happened at the beginning of the tutoring session? What did the teacher do at first? Okay, so is X going to represent the number of problems originally?
yes.
Okay, does everybody see why X is that? And I just spelled originally wrong.
Yes. And then
Okay,
each
so each student gets X.
And then each student was given 2 more problems.
So each student is going to get plus 2 as well?
Yes.
Okay,
And it equals all to 30.
and it all equals to 30. All right, so is that the tape diagram for that?
Yes.
What would the equation be? Coop, what do you think the equation would be? 5 times x plus 2. Is that what you mean?
Would it be X? Yeah.
That's what you want me to write? Is that what you see in the tape diagram?
No.
Do you see 5x plus 2 equals 30 in the tape diagram?
He said, I'm pretty sure he said 5 times x.
I did. 5 times x is 5x.
Oh.
Don't you need to put the X plus 2 in parentheses?
Yes. See the difference between the two? It's a big difference, isn't it? Okay? Everybody see that?
First.
Everybody see that? Okay? So that's the equation that goes with that. Now let's look at problem number 2. 5 students came for after-school tutoring. Priya's teacher assigned each of them the same number of problems to complete. Then she assigned 2 more problems to one of the students. 27 problems were assigned in all. So what am I going to do with this tape?
Now you should put 2
So you're
in
gonna
there because one student got 2 more
Divide
problems.
it into 5
split it into
sections.
6, basically. But
So
they're
we're
all
going to have
be
6
equal.
pieces,
Yeah.
Yes.
but 5 of them need to be equal.
Yes.
And what goes in each one of those?
X.
So is X representing the same thing as it did in this problem?
Yes.
Yes. The number of original. And then we have
27.
27. So what would this equation be, Coop?
X times.
What would this one be, Coop? I want him to see it. What's the equation for that one? Mm-hmm. Do you see the difference between the two now? Definitely, do you see the difference? Look at the tape diagram. Okay? Do we understand that now? Okay, can we solve this? What would you do to solve this one?
Multiply 2 by 5.
Okay.
Since there's 2 in each box.
Okay, so we're going to take away 10.
Yes.
So that would be 20.
And then divide by 5.
Divide by 5. So 20 divided by 5 is 4.
4.
What does that 4 mean in this story?
4 problems each.
Originally.
Oh, wait, yeah.
And I spelled originally wrong. Is there another way to do that problem?
There is, I just forgot.
Could I figure out what each of the blocks are worth? Cause aren't all these blocks the same?
Yes.
So what is each of the blocks worth?
4. Well, no.
What's 30 divided by 5?
It's 6.
6. So each of the blocks is worth 6. So is x still 4? 4 plus 2 equals 6. Okay. All right, how would we solve this one? Subtract the 2.
That gives you 25.
Okay.
Then divide 25 by 5.
Okay, and that would give you x equals 5. And what does that 5 mean in that story?
5
5
problems.
problems per student.
Is that all they did? 5 problems per student? Coop?
5 problems per student except one had 7.
5.
One had 7. Okay. So that is 5 is the original number of problems assigned. Okay? We good? All right. So our learning goal today is let's use hangers to understand 2 different ways to solve equations with parentheses. So by the end of class, I would just, you want me to jump up and down again? Didn't I do that last week?
Yeah.
If you can explain why some balanced hangers can be described by 2 different equations, one with parentheses and one without. If you could explain how a balanced hanger and an equation represents the same situation. If you could write an equation that describes the weights on a hanger diagram. And if you can find that unknown using the hanger diagram and using an equation, okay? How was the gizmos? Did that help some of you understand what to do
Yeah, it helped me visualize.
with the cups and the little counters?
Yeah.
Okay, all right, good. That's why I signed it. Because I know some of you are struggling with the tape diagrams and the hanger diagrams. This is another visual that you can go back and use. And you can always go back in and use that to play with the manipulatives, okay? All right, so I would assume we don't have any questions. How could we solve this equation by dividing first?
Four divided by 4.
We would divide both sides by 4, right? Because this is saying 4 groups of this, right? So if we divide it by 4, that's finding out what one block equals if we're thinking a tape diagram, right? Okay. How could you do it distributing first? What does distributing mean?
There's 4.
Okay.
37 plus 1.
Okay. If I have cupcakes and I'm giving out cupcakes, would each of you like to have a cupcake?
Yes.
Would it be fair if I gave everybody the same number of cupcakes?
Yes.
Okay. Would it be fair if I gave only Haley cupcakes and the rest of you didn't get anything?
No.
Okay. Haley's X. The rest of you are 7. Haley gets 4 cupcakes. Y'all don't get any. Okay. Would that be fair?
No.
Okay. The distributive property is kind of like handing out cupcakes. It is saying, I'm going to give X 4 times that. Well, what's 4 times X? 4X, right? Then we see a plus sign, so we're going to put a plus sign. Now, I can't just put 7 here because I just gypped y'all that are 7. You didn't get any cupcakes. So it's not 7, it is 4 times 7, which would be 28 equals 40. Now, if we go back to that or that hanger diagram, or a tape diagram, this, let's do a tape diagram. This is split into 4. What's in each box? X plus 7 So what is there? There are 4 x's plus 28, not 4. Okay? The common mistake is to distribute the 4 to the x and then forget about giving the cupcakes to the number. Alright? The number gets the cupcakes too. Okay?
I thought
It's-
you said that you didn't. But I thought you said you didn't give any cupcakes.
If I don't give it to you, that you would have written +7. And that's what I will see a lot of people tell me that this equals.
If you minus
Oh.
28 by 40 and then divide.
And now look at it up here. This is this right here, right? This is 4 groups of x plus 7, which is what this says. This is 7 plus 7 plus 7 plus 7. So now they got the cupcakes.
Okay, because I totally misunderstood. I thought you were saying like the new equation down there was where you didn't give cupcakes.
I did give them cupcakes,
I was
okay?
confused.
When I see this, that's when they didn't get cupcakes.
Oh.
Okay. And where does that 28 come from? 7 plus 7 plus 7 plus 7 if we go all the way back to the tape diagram. Okay? Makes sense what the distributive property is.
Yes.
Okay? Now, we can solve this by dividing by 4 first. Or we can go ahead and do the distributive property and then we would subtract 28 and then divide by 4. Okay? We've done these before where we've talked about which way do you want to do it first. This is nothing new. We've been talking about it all last week. Okay? But now we're attaching the word distributing to get that 28, which when we did the tape diagram, it was there, you just didn't see it. Okay. All right. We're gonna skip this whiteboard activity, but we're gonna do it a little bit different. Okay. All right, there's a problem with parentheses. I want you to either visualize or actually draw the hanger diagram for me. Okay, or the tape. You can do either the hanger or the tape.
Oh, okay.
Or you can do what you did on the gizmos. You can use circles for x's and dots for constants. Go ahead and draw. Model that equation for me.
Oh my goodness.
You've got different tools. Let's say you could do this for the x's and this for the ones.
Okay.
Okay?
I did it.
All right. Do you have something that might look like this? Something that looks like that?
No, but I got something equivalent.
Hmm?
I think I got something equivalent because I did a tape diagram.
Okay, so you did a tape diagram, so you did this,
Yeah.
Yes.
okay?
I still don't understand the tape. I mean, the hang.
I understand it. It's
Okay.
just, I think tape diagrams are easier.
This is one block, that's the other block, there's the other
The
block.
circles with
All I'm
X's
doing
and
is
X's.
turning it sideways.
Oh. It's
Okay.
so confusing.
And the circles are X's and the numbers are in a block, in a rectangle. Okay? If you understand that, use that. If you wanna use this, I would have done 2, 3, 4, 5, 6.
Wait, how come it says X with plus? Wait, is that completely different?
So So if I was using like you did in Gizmos, I'd have 3 groups of these, and then on the other side I'd have 21 ones,
Oh, I thought you
21
were
plus
saying
5.
like, I thought that was a part of the hanger diagram, the
No,
X plus,
no.
I thought you were saying X plus.
Okay?
Oh,
That's using like you did on Gizmos. Okay? Alright. Can you solve this using division first?
yes,
What would you do?
21 divided by 3.
Divide by 3, because you're gonna take this, you're gonna divide that here, divide that there, or you're gonna think about what is each block worth, right? So, showing it math-wise, I'm gonna show you with the equation now. Let me move this over. Math-wise, you will do the upside-down T. We are going to divide both sides by 3 using the division property of equality. 3 divided by 3 is 1. So that leaves me x plus 6, which is what this one section is, or this one block is. 21 divided by 3 is 7. So we are saying here that this x plus 6 equals 7. We're saying here that each one of these is 7. Okay, tying it back to what we did before. All right, I want to get x by itself. What's hanging there with x? 6 is hanging there. How do I make 6 go away? Subtract 6 from both sides, so I get x equals 1. Okay, that's using division first. Copy that math down, or take a picture of it. That's my expectation of what work looks like. If I don't see work, you don't get credit. So either take a picture or write it down, I don't care. That's using division first when there's parentheses. Okay, now we're going to do it distributing first. Everybody got this written down?
Yes.
Okay. Okay, we're going to distribute first. We're going to hand cupcakes to everybody inside. So this gets multiplied by that, so that gives us
3x.
3x. See a plus sign, put a plus sign. Then the 3 must be distributed to the 6 as well. 3 times 6 is 18 equals 21. Well, where did that 18 come from? If you look right here, we got 6 plus 6 plus 6 is 18. If you look up here, we have 6 plus 6 plus 6 is 18. That's where the 18 comes from. Okay? Now, what's hanging with the 3 x's? 18. How do I make it go away? Subtract 18. So now I'm left with 3x equals 3. I don't want 3 x's, I want 1x. How are these connected to each other? What operation?
Multiplication.
How do I undo multiplication? So I'm going to divide both sides by 3. 3 divided by 3 is 1x, and 3 divided by 3 is 1 over there. Okay, that's distributing first. So when you're looking at a problem that's got parentheses in it, you have 2 options. You can divide first, or you can distribute first. Both ways work. Okay, so copy that down. Now notice when we divided, it divided evenly, right? We're going to do a problem where it won't. And then I'm going to tell you, don't divide first. Okay? If it doesn't divide evenly, don't divide first. distribute first. Because otherwise you're gonna be dealing with fractions. And how many of you like fractions? You like fractions? Most of us don't, okay? So why make it harder than we have to, right?
Fractions are not my friends.
Fractions are not your friend. All right, so let's go back to this, and we're gonna start the practice problems. Go back to that. Thank you. All right, here's a hanger. Let's write an equation to represent that hanger, and then solve the equation by reasoning about the equation or the hanger. Actually, we're gonna kind of do both, and explain our reasoning. All right, Max, what's the equation that goes with that hanger? Well, we're actually going to put x plus 2, but 2 plus x is fine because of the commutative property, but proper form puts the variable first. Then what? Times 5. That. And it's going to equal 11. Okay. What do we think about that? Anybody want to bounce off of that? Do you agree, disagree?
I think I agree with what he's saying, but I think he could put it different, like.
You can, it's just,
Yeah,
with that one, you don't have to put the
multiplication
parentheses.
sign.
All right, so how would I show that it's times 5?
You put 5, and then you can put parentheses, and then you put x plus 2 in there, and then put parentheses, and then put equals 11.
So you're saying, what I heard was this,
Yeah, that's what I'm saying.
Yes.
okay?
So like, I agree with what he's saying, but I think.
Could I have also done this?
Yes.
Yes.
Yes. Okay, it can go in the back. All right, the correct way to say this is 5 times the sum of x and 2. As soon as I say the sum of, that means you gotta do this first. Okay? Or you can say 5 parentheses x plus 2. Okay? Got it, Max? Thank you for doing that for me. I appreciate that. Let us have a good conversation. So do we all feel comfortable about this now?
Yes.
Okay. Now we're being asked to solve it either using the diagram or the equation. Would you divide first?
No.
Would you divide this by 5?
No.
No, because 11 divided by 5 is not a pretty number, is it? So, we're not going to divide first. We're going to distribute first. So 5 times x is 5x. We gave them cupcakes. See a plus sign, put a plus sign. Now we have to give cupcakes to the other one. 5 times 2 is 10 equals 11. Well, come over here and look at this. Do we end up with 5 x's here?
Yes.
Do we end up with 10 over here? Okay?
Yes.
All right. Now, what do we need to go away?
The 5. Wait, no.
Think about what am I going to get rid of first over here?
The 10.
The 10. I'm going to get rid of the 10 first. So I'm going to draw my upside down T so I can show both sides. I get 5x equals 1.
Then you would do. Oh.
What's connected to the 5? The x.
Multiplication.
Multiplication. So how do I undo multiplication?
Division.
Division.
Division, I'm going to divide both sides by 5. So that's going to give me x equals 1/5. It's okay if the answer is a fraction. Think about it if we looked over here. 2, 4, 6, 8, 10. Take away 10 there, we get 1. Well, what are we going to do to this one? We're going to split it up into fifths, right? Each x is going to be worth 1/5. Questions? Okay. Are we finished with this one?
Can I
Don't we have to prove our solution? So we're gonna go back to the original equation and plug in 1/5. Does that equal 11? Okay, what is 1/5 plus 2? 2 and 1/5,
Oh.
right? Okay, 5 times 2 is 10, 5 times 1/5 is 1, 10 plus 1 is that what I needed? Did we just prove that our solution is correct? Yes. That is always your last step, prove your solution is correct. Questions on any of the steps? Did I lose anybody? Those of you in the back don't look like they're completely with me. Can you see it in the hanger diagram if you need to go to the hanger diagram? Okay. Who needs more time to copy? Okay. Next one. Explain how each part of the equation 9 equals 3 times the sum of x and 2 is represented in that hanger. Hey, where are the x's in this hanger? Say over here on the right hand side? Here, here, and here. So that is represented by that. Where's the 9?
On the left.
On the left. It's not on the right. It is right. There's the 9. Okay, so that's the 9. Where's the 3?
The 3 X's. Oh. Wait, it's right.
Where's
There's 3 groups.
There are 3 groups.
What is
Here's 1 group. Here's 2 groups. Here's 3 groups. So there are 3 groups. Where is x plus 2?
There's 1x and then 2 1s in
Uh-huh.
each group.
So if I look at these dashed lines, is that my x plus 2? Because those 2 1s make plus 2. Okay. Okay. Where is 3 times the sum of x plus 2? Where are they getting 3 times the sum of x plus 2?
on the right?
On the right hand side, it is 3 groups of x plus 2. Where's the equal sign?
On the
Bar.
The bar. Good.
Isn't it the bar?
Yep, there's your equal sign. If it was slanted, it wouldn't be an equal sign, it would be an inequality sign. Alright,
I'm just gonna
take a screenshot of it, it's probably the easiest way, and then you can draw it later.
Hold on.
You want me to get out of the way?
Oh, you know, I took a second one and
Very good. Okay. Problem number 3. We're going to review some vocabulary after looking at that percent quiz on yesterday. Yeah, we need to review. We're going to review some of those problems too. You deposit money in a savings account, and every year the amount of money in the account increases by 2.5%. Is that tax, commission, discount, markup, tip, or gratuity, or interest? Interest. For every car sold, a car salesman is paid 6% of the sales price.
commission.
Commission. Someone who eats at a restaurant pays an extra 20% of the food price, and that money goes to the server. Tip. Or gratuity. An antique furniture store pays $200 for a chair, adds 50% of that amount, and sells the chair for $300.
Oh.
Markup. That's their profit, right? Okay. The normal price of a mattress is $600, but it's on sale for 10% off.
Discount.
Discount. I'll put a triangle around that.
So obviously the last one's tax.
Yay! For any item you purchase in Texas, you pay an additional 6 2/2500% of the item's price to the government, and that would be tax. All right, we got one more problem. Anybody need more time? Okay. A goes to 6, B goes to 2, C goes to 5, D goes to 4, E goes to 3, and F goes to 1. All right, are you good? Okay. Last problem. There we go. Claire drew this diagram to match the equation 2x plus 16 equals 50, but she got the wrong solution as a result of this diagram. What value for x can be found using this diagram? So let's find x in this diagram. What are we going to do first?
Take away the 16 and the 2.
Let's take away the 16 and the 2. That's going to give us 32. Are we done now?
No.
Yeah, we are. We got x by itself. X equals 32. She got a solution of x equals 32. And her teacher said, wrong answer.
Oh.
Show how to fix Claire's diagram to correctly match the equation.
Well, I would say, I think her tape diagram, she wrote it wrong because she already isolated x, and in the equation, it's saying that the x is attached to 2, so it would be 2 x's, and then there'd be 16.
Is that what you're saying?
Yes.
Okay, anybody want to bounce off that? I agree. I disagree. You agree? Okay. You agree? All right. Use the new diagram to find the correct value for x. So what are we going to do first?
Take away the 16.
Divide by, or take away 16. Take away 16, okay. So 16 goes away there, 16 goes away there, that gives us 34. And
Divided
what?
by 2.
Then 34 divided by 2 is going to give us 17. Now our teacher's happy, she got x equals 17. Explain the mistake Claire made when she drew her tape diagram. Liam, what do you think? Where did she go wrong?
She messed up because she isolated the x.
So does this show 2 x's?
No.
It only shows.
This
It
shows
2
2,
plus
the
x
number
plus 16.
2,
Oh,
plus x,
Plus
plus
16.
16.
I was going to say she drew 2 plus x plus 16.
Yes, this is 2 plus x plus 16 equals 50. And is that the same as that? No, because this one only has 1 x in it. Okay? Good job! And you all said you don't like tape diagrams.
Depending on what it is.
All right, anybody need more time? Looky there. I got through it. Next steps. 1, upload a picture of what you just did. Put it on the Google slide so you don't lose it. You have for independent practice, you have a quizzes. Unit 6, lesson 8 is the name of it. then upload the picture of that. Goal is an 80%. Please do the lesson 9 slides tonight. And then please work on Imagine Math. All right? Alright, I will see you tomorrow. Those of you that are craving live, you will do the math benchmark. Those of you that are sitting in front of me, you will do the math benchmark tomorrow morning. Alright? Have a good evening. You can tidy up. Who in here is going to the Mars party?
I'm going to Miss Wagner.
You know where you're going? See that piece of paper right there? Find your name on that piece of paper and that will tell you where you're going. Okay. Bye.
Honestly, I think the favorite thing that we learned now.
Oh, Miss Lair, I did those slides for today.
I think my favorite thing that we learned now.
Circle.
Yeah, it was circle.
Circumference. Like I said,
I like
circumference.
the
Or is just circle in general? That circumference is put over there.
So will I wait in here until
Yeah, we don't have to go outside.
Yeah.
We don't have to be in church.
Miss Lair.
Yes.
Still remember if it costs money.
Yes.
no, it doesn't.
I did the slides for today.
Yay! When I see you on Monday, I'll give you
All you have to do
candy.
is bring it to your parents.
Okay.
Okay, remind me.
You just type it.
Alright.
I
Okay.
used some type of version, so I
Bye.
didn't know if it's gonna
Have a good
cost
evening.
anything, so I just didn't follow through.
We are going to get this.
Because unless it's a few different, we don't spend the money.
Yeah. Was it icy paint? Yeah.
Sorry, what do you?
Did anybody do anything fun for those 5 days?
No. I watched like 4 shows. I finished them like in 1 day.
What shows?
There, I don't know. I forgot the name. I watched a lot.
I've been watching Firefly.
The buses are awesome. You live in North Carolina.
Yeah, because
Miss Blair.
You went to Target with
I have kids too.
My little sister got a
Oh no.
outgrowing everything.
They're really old. You should look at that. My mom just sent me with
They're so cute. Yes, I have to stay out of the Carter store. I can go in there and drop $100.
Twitter, Facebook.
I think you do it for me. Oh, hello.
Hello.
That's a good, yeah.
Oh, I forgot to take it from the.
Oh yeah, you talked to us all.
Oh, I didn't turn that off.
Shine.